Hi class, in this video I want to do a brief introduction to section 4.1, which is about Pythagoras and his hypotenuse. Okay, so what this really has to do, this section has to talk about is something called the Pythagorean theorem. And you might have heard of this theorem in your previous math courses, but it just goes like this. In any right triangle, the square of the length of the hypotenuse, okay, so this is a right triangle that you see here. So we call A and B the legs, and the long side of the triangle opposite the 90-degree angle is the hypotenuse. So the square of the hypotenuse, so whatever the length is, c squared, is equal to the sum of the squares of the lengths of the other two sides. So meaning for any right triangle, it will always hold that if you take a squared and add it to b squared, it will always equal to c squared here. Okay, so what I want to do now is I just want to walk you through two quick problems using this Pythagorean. So I'm a baseball fan, so we'll start with this. A baseball diamond is really a square measuring 90 feet on a side. So from home plate to first base is 90 feet. From first base to second base is also 90 feet. Second to third is 90 feet. And third to home is 90 feet. How far does a catcher have to throw the ball to get from the home plate here to the second base here? Well, so if you think about it like this, if you were to just draw, and maybe I'll help with this here. If you were to just draw from home base to here, okay, that's where the catcher has to throw. This right here is a 90-degree angle. So we're asking us to find the length of this hypotenuse C here. Okay, this is my A, this is my B here. So what we're seeing here is that 90 squared plus 90 squared is equal to C squared. And sorry, my writing there is bad, but we can just grab our calculator here. 90 squared plus 90 squared is, wow, it's that, right? It's 16,200. Well, now that's equal to C squared, okay? That's what C squared is equal to. So to find out what C is just equal to, we actually just have to take the square root of this. And you see it's 127.28 feet. So the catcher to go throw from home to first, or home to second, excuse me, is 127.28 feet. So just whenever you have to undo a square, you have to do a square root. All right, let's do another one here. Okay, this is kind of a problem that's very similar to one of your homework problems. Okay, the sailboat named Sandbug has a tall mast. Okay, the backstay. Now this is the backstay is what's defined as the heavy steel cable that attaches the top of the mast to the back stern of the sailboat is made of 130 feet of cable. Right, the base of the mast is located 50 feet from the stern of the boat. How tall is the mast? Okay, so let me draw this to help. Forgive my very crude drawing here. Okay, this right here is supposed to be the mast of the ship. Okay, here's the boat. This is a bad looking boat. Okay, but you get the idea. And at the top of this here, there's this cable that connects to the back of the ship. Okay, and what we're saying is from here to here is 50 feet. And they were telling us the length of this cable is 130 feet. Right, so what we're seeing here is this right here is a right triangle. So it's asking us to find the value of A here, okay, the height of the mast. So this is A squared plus B squared, well, that's 50 squared, is equal to 130 squared. All right, so let's grab our calculator here. First thing I'm going to do is I'm going to subtract the 50 squared over. So what we're seeing here is A squared is equal to, and I'll go back to my calculator in a second, 130 squared minus 50 squared. So my calculator can do this for me real quickly. 130 squared minus 50 squared. That's this. Well, now to just find A, so remember, A squared here is equal to whatever this was, 14400. Now just to find A, we square root that value. And it looks like the height of that mast, of that sailboat there, is 120 feet. Okay, I hope that helped and was a good introduction to the Pythagorean theorem for you.